So let's calculate the surface area of cylinders. There's a picture of a cylinder, and I have a couple of cylinders here to show you. Some of them fit the camera here. How about this one? A cookie jar. The cylinders don't necessarily need to be that tall and not wide. How about this kind of cookie jar? It's a lot wider and it's a lot shorter. And it doesn't have to be sheet metal. How about this one? A plastic cylinder. And see, or cylinders that you might come across. How about you might want to make a hot water tank one day, or a patch for it, a boiler, or anything of that nature, cylindrical. It doesn't have to be a full cylinder. It can also be hollow like this, just the lid of something, you know, a cylinder with a bottom, a side, but no top. It's still a cylinder, just it doesn't have a top. So cylindrical shapes are fairly frequently found in trades. So why would we want to do the cylinders? You might want to do cylinders because you need to know the square footage of material that goes into it. It could be, again, metal, sheet metal, I don't know, half-inch thick plate steel, whatever it is. Could be plastic. So whatever you're manufacturing, you might need to know the surface area. You might be painting one of these and you need to know the surface area of it. So, and common objects include hot water tanks, boilers, cylindrical chimneys and chimney flues, or any kind of exhaust systems, even the cylindrical exhaust components on vehicles, you know, and not only manufacturing but patching, fixing, repairing, maintaining, painting over, also involves working around surface area of cylinders. Alright, before we can get to work, you need to realize what shapes this cylinder is made of. It's not made of circles, okay? Well, the lid is a circle, so far so good, and the bottom is a circle. However, what happens to a cylinder? Let me just grab my tin snips here. Here is my tin snips. Now, what happens to a cylinder when it meets a tin snip is that it shows you what actually getting there. What shape it is actually made of. Just give me a sec here. I'm gonna make a map plan of a cylinder. There. So there's your lid. There's your bottom on the cylinder, or the other way around, whichever way you like. And then the middle or the side wall of the cylinder cuts up like so. And then we have a shape that looks like this. Okay. I'm going to hold it like so. So we have basically two circles, and what is this shape between the two circles? If I kind of try to take away my fingers from it, yes, ladies and gentlemen, you have a rectangle in the middle here. Rectangles can be calculated, length times width, and cylinders can be calculated, r square pi. I say let's get to work. Sorry, it's on this side. I drew the mat plan of the cylinder this way. The two circles don't have to be symmetrical, or they don't have to line up. This is also the same idea for a cylinder. And the area of this circle, that's not A0, that's the area for the circle, so that's a little circle as an index there, can be calculated with the well-known formula of radius square pi. The area of this rectangle can be calculated with the well-known formula from grade 4 or so, length times width. Oh, sorry, let me just... length times width. Okay, and we have two of those circles, so all we need to do is double the area of one circle and add the area of the rectangle. So why don't we calculate the area of this cookie jar here? I like this one, and it's got a diameter of, let's go metric. Okay, I like I don't want to do fractions, just so you get the numbers, and I'll give you whole numbers so it's easy. Say the diameter is 20 on this one. The diameter of the cylinder is 20, and the height of the cylinder is 7. How about that? Everything centimeters, but don't worry about the centimeters too much for now. 20 centimeters. And the height of the cylinder, I'm gonna write height of the cylinder, that was 7 centimeters. Okay, you gotta remember that diameter is twice as long as radius. I measured the diameter this way across the cookie jar, and for calculating the area of that circle you're gonna need radius. So what you do, you gotta make radius by chopping that diameter into 2. So the radius of the circle is 10 centimeters. From here on, it's easy sailing. It's the area of the circle is 10 times 10 times pi, which will equal to, because pi is 3.14, I'm not gonna do it on a calculator, okay, please. It's 314.15 centimeters squared. Now, there's your r square, radius times pi, everything is there, 314.15. So far so good for circle number 1. Circle number 2, area of this circle is also 314.15. So it's an easy kill. Now, this is where the tricky part is. The height of this cylinder, I said it was 7 centimeters, and when the cylinder is made into a matte plan, you don't see the height on this anywhere. You gotta realize that the height of the cylinder, the height of the cylinder, when it's folded out, becomes the width of this rectangle. Okay, whatever was height on this cylinder, it becomes the width of this rectangle. Is that making sense? I hope it does. That's why I wrote it there. It wasn't coincidence that the height, I wrote it next to the width, because the height is the same as the width. Okay, the height of the cylinder is becoming the width of this rectangle. It just becomes magic, okay? Now the length of this rectangle needs to be considered carefully as well. And watch my hands, because I'm cheating here, as usual. When the cylinder is together, you see that this circle here fits this rectangle in an interesting fashion. The length of this edge on this rectangle fits this feature of the circle. And what is this part of the circle called in terms of circle terminology? You can see that this rectangle just curls up there. The rectangle just curls up there, like so, to be this part of the circle. And that, ladies and gentlemen, is the circumference of the circle. So that length becomes the circumference of the circle. Well, actually the circumference becomes the length of this rectangle. And if you remember, the circumference of the circle was calculated by the formula diameter times pi. That's jolly good. We already have the diameter, 20 centimeters. We just have to multiply it by pi. Pull out your best calculator. And let's do some numbers. There we go. Diameter was 20 multiplied by 3.1415 equals that number, 62.83. That's accurate enough for this one. Of course there is a pi button on this one, okay, but it works this way too. 62.83. That's centimeters of length, okay, because it's a length on a rectangle, and it's the circumference is a length type thing. So what you have is length on this one, width is the same as the height of the cylinder was, so you times it together to get the area of this rectangle. So 62.83 multiplied by 7 equals 439.81. And that's centimeters squared now, because this is area. That was length, that's length, but that's area now. What you need to do is add everything. By everything I mean that one there for the first area of the first circle, that number there for the area of the second circle, and that number there for the area of the rectangle in the middle. What you do is 439.81 plus 314.15 plus 314.15 equals 1068.11. So we concluded that the area of my cookie jar cylinder, the area of my cookie jar cylinder, this one, was 1068.11 centimeters squared. End of calculation, but we're going to do a little algebra with this one. So that's the process. You can do it by breaking it down into its elemental two-dimensional shapes and add them together. Add the circle plus a rectangle. It's totally doable. We also have a formula for all of this thing. It's not gonna be, it could be a little faster, however I like the first version that I have shown you by adding it from its elemental components, because with the formulas, if you remember wrong, if you miswrite your formula or misremember it or make any kind of mistake with it, your formula will be tragically off and your calculation will be incorrect, with no hope of ever finding the fault or the mistake in it. So what we did, and this is how we create the formula, we calculated the area of the circle, that was r squared pi. We calculated the area of the second circle, r squared pi. Then we calculated the area of the rectangle, length times width. Length was the same as the circumference of the circle in the cylinder, so there's your diameter pi, and width was the same as the height of the cylinder, so there's everything, all the components and everything was added up to get to a grand total. So theoretically, I can write up this formula. I can create a formula if I just add everything together. And if I do so, add everything together, and after all the addition is done, I can maybe factor out the common factors in the components. I arrive to this formula. This is the formula that can help you calculate the area of the circle, and this formula works perfectly fine. How it relates to what we've done is this. If you remember from the previous slide, because I can't have two slides here, this is what we did. We had I'm just going to change color here. What we did was radius square pi, and instead of radius square, can I just write radius times radius, because that's what squaring is, you're timesing it by itself. So I'm just going to go radius times pi. That was for the area of the first circle, but we had two of them, so can I just please write a number 2 there because we had two circles. Okay, so now we have that one, and it's beginning to look like that formula up there. We're gonna get there. And then to this we added a length times width business. So that was the two circles, and then we had the rectangle that was length times width. Now length was diameter pi, because that was the circumference of the cylinder becomes the length on the rectangle. What was it? Length times width, and the width of the cylinder was the same as the height of the cylinder was the same as the width on the rectangle. Okay, so we've got all this stuff here. That's what we did. We can. Oh, sorry. That should be a cylinder. My bad. There. That's the area of the cylinder. So the area of the cylinder. This is what we did. We had r times pi. We doubled it, and then to it we added length times width, which is circumference of the circle times width becomes height. Okay, or height becomes width. That's good. That's what we did, and this formula is almost the same as that one. What we need to do is factor out. Actually, can I just, instead of diameter, a diameter is twice the radius. Can I just write that instead of that, 2 times radius, because it's the same thing. There. Okay, can I just factor out at this point from this line of bunch of letters some of the letters that are common in both terms of the addition. You can see you have a number 2 here and a number 2 there. You have one piece of radius there and another piece of radius there. We have 1 pi there and 1 pi there. So these 3 terms are common and they can be factored out because they repeat in both. So if I just group them here and just write 2 times r times pi, then what is it that's left and unaccounted for? So that's on the outside of the bracket. What is unaccounted for is that and that and that. So what we write is radius plus the height. Alas, we got back the formula. Now we started with all for the calculation of the area of the circle. Now if this algebra is a little steep, don't worry about it, but this may help you. So I understand some of the learners find it useful. If don't worry about it. You can calculate the surface area of the cylinder by breaking it into its individual 2-dimensional geometric shapes and go from there. And if we do the last 30 seconds here, if we have this formula and get rid of the bracket, what we get is we have to multiply everything in front of the bracket, the factor, the common factor, by that. If we do that, we get this 2 times pi times r times r, and then in the bracket we've got h so far, and then we have to multiply everything outside of the bracket with h as well, so that doesn't look good. 2 times pi plus we've got 2 times pi times r times h. There. If we multiply every term outside of the bracket, all of the factors, with the terms inside the bracket, that's what we have here. And if we rearrange just the order of these, we have already written this one up. 2 times r times pi is here, and 2 times r times pi times h is here. 2 times r times pi times h is here. So either which way, it's the same equation, the same formula. What an equation is an extremely shorthand version of the procedure that we actually did. An extremely shorthand version, because what that one says is exactly what we did here in the first place. So that's calculating surface area of cylinders. Let's do some practice.